Hi students, today we will discuss about the polymer that this is the continuation of our previous classes. So we are discussing about the polymer, you can remember. So today our lecture number is 31 and as you know the module is 4 and the chapter name is polymer. Okay, so these are the some of the course objectives of our subject, that is chemistry. That is the name of the subject. The subject code is CH101201. The credit is 3 and contact hour is 35. Okay, so these are the some of the course objectives that we have for our course. That is, the concept developed in this course will aid in quantification of several concepts in chemistry that have been introduced at the 10 plus 2 levels in schools. Technology is being increasingly based on the electronics and molecular level modification. Okay, so these are the some of the course outcomes that we have for this subject, that is the chemistry. You can able to, after completion of this course, you can able to describe the fundamental properties of atoms and molecules, and also you know about the atomic structure and periodicity of the elements in the periodic table. Also you can able to apply the fundamental concepts of thermodynamics in different engineering application. You able to apply the knowledge of water quality parameters, the corrosion control and the polymers to different industries, and you can determine the structure of organic molecules using different spectroscopic techniques, and also you can evaluate the theoretical and practical aspects, that is relating to the transfer of the production of some of the chemical products in the lab to the industrial scale. So these are the some of the course outcomes that we have for our course. Okay, so this is the lecture plan for our lecture for our chapter, that is a polymer. Okay, so this is the objective of today's class. Today we will discuss about the classification based on the polymerization reaction. As I told you earlier that the classification of polymer is very important. Okay, so from this portion there are so many questions you may ask in your exam. So today we will see the classification of the polymers, which is based on the polymerization reaction. Also we will see the biopolymers, what are the biopolymers and what are the conducting polymers and what are their uses, what is the utility of this, and what are the examples of biopolymer and also the conducting polymer. Okay, so this is just the recapitulation at a glance, that whatever we have discussed in our previous class. That is, we have discussed the classification. We have classified the in our previous class. We have classified the polymer based on the thermal response. We have classified based on tacticity, and also we have classified the polymer based on the intermolecular forces. So these are the three classifications that we have discussed in our previous class. As this is the continuation, I am just repeating again all the topics. It's just a rapid recapitulation. Okay, so this is the classification of polymer. It is very important. So polymers generally we can divide into four groups, four categories, that is based on source, based on structure, based on reaction mechanisms, based on molecular force, intermolecular forces. Okay, what are the types of bonding, what are the types of intermolecular forces we have for the molecules in between them. Based on that we have the classifications, and rather than this also we have the classification based on tacticity, classification based on the thermal responses. Okay, so here the natural, based on source we can divide, we have the natural polymer, synthetic polymer, semi-synthetic polymer and synthetic polymer. Based on structure there are three types of polymers that we have, that is linear polymer, branch chain polymer and cross-linked polymer. Okay, based on reaction polymerization that we will discuss today, that is the addition polymerization and condensation polymerization, and these are the two classifications that we have made based on the monomers. Okay, that is homopolymers and copolymers. And next, based on molecular forces we have elastomer, fibers, and also we have thermoplastic and thermosetting polymer, which is based on the which is the classification that is based on the thermal responses. Okay. Okay, so as I told you, based on thermal responses, there are two types of polymers we have, that is thermoplastic and thermosetting. Thermoplastic and thermosetting. Okay, so these are the thermoplastic. Generally thermoplastic polymer, in between the thermoplastic polymer we have very weak intermolecular force, that is van der Waals force, very weak. Okay, so while there we heat that polymer, heat the thermoplastic polymer, that will melt. Okay, and then again they can be made in different shapes, and while on cooling the thermoplastic materials again become the hard. So why? Because of their only that is possible only because of their because of the weak intermolecular forces. Okay, so polystyrene is one of the example of thermoplastic polymer. Again we have polyethylene, polypropylene, polyvinyl chloride, all these are the thermoplastic polymer. Now thermoset polymer generally we have the cross-linked. Okay, cross-linked or network structure. The chains are the all the linear chains are interlinked, connected, cross connected. Okay, so cross linked, that is why it's called cross linked polymer, and that is why this polymer is very stable and they have the strong covalent bond, and for which they are very hard. Brittle, they are very hard and brittle, like also bacillite is one of the example of thermo setting polymer due to their network structure. Okay, so in case of thermosetting plastics with thermosetting polymer, what will happen? The cross links prevent the displacement of the polymer. While we heat that polymer, the polymer cannot be displaced, as because of this strong bond. Okay, so on heating they don't soften. So these are the some of the special features for the thermosetting polymer. So these are the differences of thermoplastic and thermosetting polymer, which is very important. Okay, thermoplastic polymer, generally what will happen, they are addition polymer. They, after heating, they will soften, and on cooling they will become hard. Thermosetting, for the thermosetting polymer, what will happen? Condensation, due by the condensation polymerization, they will form. They have the 3D network structure, which is very strong, and thus they doesn't become soft on heating. These are the some of the differences between thermoplastic and thermosetting polymer. Okay, now we have the based on we have polymer that is based on the tacticity. Generally we have the isotactic polymer, syntactic polymer and atactic polymer. Isotactic polymer, that means you can see, if you see this polymer, all the red balls are the in same position. Okay, so if we are considering these are all alkyl group, all alkyl groups are in the same position, so that is called isotactic. Now if it is if you are looking at this syntactic polymer, you can see the red balls are in the alternate position. If it is upside in one atom, then in the next atom it will be downside. So this alternate position will be maintained throughout the whole chain. So this is called syntactic. And atactic, if you are seeing, if you are checking this polymer, you can see there will be no such specific periodicity in the structure. At some time the red balls are at the same side, at some time it will be alternate position, so their arrangement is random, so that is why it's called atactic polymer. Okay, next, polymer can be divided into three groups based on the intermolecular attraction force, that is the elastomers, fibers and plastics. Generally elastomers are the having weak van der Waals forces, and they are very soft, like Bunaes, Bunae, neoprene. These are the some of the examples. Okay, and these are the plastic, you know, daily we are using so many plastic materials in our daily life. So generally their intermolecular forces, attraction force is in between elastomers and excuse me, in between elastomers and fibers. Okay, so they are partially crystalline. They are mostly held by the weak van der Waals force of attraction, but dipole-dipole interaction. Okay, so these are the some of the examples of plastic that we are regularly using. Now fibers. Fibers are generally two types. One is natural, one is synthetic. You know all natural fibers. What are the natural fibers? Like cotton, linen, wool, silk. They are all the natural fibers. Okay, jute, natural fiber, kenaf, natural fiber, hay, natural fiber. Okay, bagasse, natural fiber. So these are all are the natural fibers. And synthetic fibers, we know that is rayon, nylon, polyester, acrylic, terylene, PET bottles, PET, PET bottles. So these are all the synthetic fibers. So fibers are, what are the examples, what are the specific features of fibers? Fibers, actually what will happen, they are thread like structure. The structure is long. Okay, so and their intermolecular force is to some extent higher than the elastomers and than the plastics. So these are the some of the features of the fibers that we have. Now come to the today's topic, that is a classification based on polymerization reaction. So polymerization reaction, based on this we have two types of polymers. One is addition polymer, one is condensation polymer. So addition polymer, you can see that addition polymer, you can see that is like polyethylene. These are the examples like polyethylene, polypropylene. Or condensation polymer like nylon 6,6, nylon 6. These are the all the condensation polymer. Now we will see in details. So addition polymer means while the monomers will be added with each other and form a long molecule, a large molecule. Okay, like polyethylene. If we take the ethylene molecule and attach one by one, so what will happen? It will make the polyethylene, the plastic molecules, the large molecules. Okay, so generally for the addition polymerization, if we look at the mechanism, we can see there will be no no loss of the molecules which we have in the condensation polymerization. Okay, so generally addition polymerization, what will happen, we have a molecule and that will add one by one monomers with the all monomers while adding with each other and forming a large molecules, that is called the addition polymerization. This is the type of polymerization in which the molecules of a similar monomer or different monomer add up together on a large scale to form a polymer. When we keep adding monomers to obtain a large chain, such a process is called chain growth polymerization. Okay, the monomers that are used here are unsaturated compound, exactly. So here you can see like ethylene, styrene, propylene. So all these having the unsaturated bond. So while we have the all the monomers should have the for this polymerization reaction, all the monomers should have the unsaturated bond. Okay, the carbon compounds which are connected by a dipole or double or triple covalent bond. Okay, so in our monomer moiety, obviously there should be a double bond or there should be a triple bond. An addition polymer is a polymer formed by chain addition reaction between the monomers contain double bond molecules of like ethylene. Yes, this is the ethylene molecule. You can see we have here double bond. So while all the ethylene molecule will attach with each other and it will make the polyethylene. N is the number of monomer unit and that is very large integer. Okay, so this is the now come to the mechanism portion. So there are three steps we have. One is initiation, one is propagation, one is termination. First we have to initiate. Okay, so what will happen, this is the alkoxy moiety. Okay, so what will happen, this group will attach with this one electron with this double bond. Okay, you can see, so this double bond will break. Now we will have this type of moiety. That means the chain initiation first of all will take place with the help of free radical. Okay, free electrons but free radical, these are the called free radical, RO dot, that will attack the double bond of the ethylene moiety. What will happen then this RO, this double bond will break and the free radical but the electron will be on the carbon atom. Previously it will be on the oxygen atom. After joining, it will on the carbon atom. Now this free radical again attack the another ethylene moiety. Okay, so another ethylene moiety it will attack and what will happen, this type of again the free radical will be forming. So this is called propagation. The formation of the propagation process will be going on through the formation of the free radicals. Okay, so these free radical again attach with another ethylene moiety and it will again form another free radicals. Now termination. So termination means whatever this type of free radicals whatever we have, so while these free radicals again attach with each other and it will make a huge molecule, and this is called the termination process. So first of all, initiation process, the first step is initiation process. That means the free radical will first initiate the reaction and this free radical and again form the more free radicals. Then these free radicals again act at the more ethylene molecule and forming this type of free radicals. And in the termination sector, whatever free radicals we are having, so that free radicals joined each other to form the large molecule, and which is called polyethylene, or which is the reaction mechanism, which is the yes, synthetic pathway by which we are having the addition polymerization, like polyethylene, polypropylene, polyvinyl chloride. Okay, so these are the some of the reaction mechanism. Okay, so again I have shown you the reaction mechanism. We have the initiation process, then we have the initiation process. Mainly you have to remember the free radical. We need the free radical for the as the initiator. Okay, then we have the propagation system, propagation step, and then we have the termination step. Okay, termination step means whatever free radicals made, so that free radicals while attached with each other, and they are forming the huge molecule. So these are the some of the mechanism. Now this is the examples of the addition polymers. Generally this portion is very important. Okay, so these are the some common addition polymers, that examples of common addition polymers that I have given. The monomer, what are the monomers for that addition polymers, the structure and the uses. So from this portion you can have this type of question like, what are the monomers of like polyvinyl chloride? Okay, what is the use of polyvinyl chloride? Write down the structure of polyvinyl chloride. Write down the structure of monomers of the Teflon. So these are the some of the questions, tricky questions that you may have in your exam. So this portion, these examples, the monomers, the structure and the use, you have to memorize very well. Okay, so first we will see that is the polyethylene. Polyethylene, that is plastic material. So first the ethylene is the moiety, and while so many ethylene moiety will attach with each other and it will make the polyethylene the molecule. This is the structure. Okay, and poly bags, toys, squeeze bottles. So these are the uses are made of this polythene. Next, polystyrene. Polystyrene, the monomer will be the styrene moiety, and this is the structure of the polystyrene. So generally we use the polystyrene like combs, toys, radio, okay, and buttons. So these are the some of the uses of the polystyrene. Now PVC, what is the full form of PVC? That is polyvinyl chloride. So vinyl chloride is the monomer. Vinyl chloride is the monomer, and this is the structure. Generally we are using this PVC as a packaging, wall covering. So these are the use of PVC. Now Teflon, we all know what Teflon is used. Teflon is tetrafluoroethene. Okay, CF2. This is the monomer. Teflon generally we use in the cooking utensils, non-stick cookware. There we have the Teflon coating. Okay, so this is the use of the Teflon. Now neoprene. Okay, but Buna S. This is very important. Buna S. Buna S means butadiene and styrene. The monomers are butadiene and styrene. Okay, so you know that rubber, Buna S rubber is used where you know actually. So these are the now Buna N. bunine butadiene and acrylonitrile. So from this portion you can have this type of question like, for buna S, what does it mean by S? S means styrene. For buna N, what does it mean by N? N means what? N means acrylonitrile. So these are the some of the examples of addition polymers, the uses, their monomers and their structure. This portion you have to memorize well. Next we will move to the next topic, that is the condensation polymer. Now generally what will happen for this condensation polymers, polymerization reaction, obviously some of the molecules will be eliminated during the reaction. If you see the reaction mechanism, you can understand either water molecule will be evaporated or acid molecule will be generated, so that you can see. Okay, so this type of reaction involves the repetitive condensation between two bifunctional monomers. Yes, the monomer should be the bifunctional, right? Acid group, one acid group is there, where one amine group is there, so that will attach with each other through the condensation polymerization reaction, and they will belong to this category, that is condensation polymer. There is a loss of some simple molecules such as water, alcohol due to the condensation mechanism. As I told you, if we see the mechanism, you can see that while the reaction is going on, so through the mechanism, some of the water molecules, some of the alcohol molecules can be eliminated. Okay, condensation mechanism refers to combining of smaller molecules to obtain larger molecules. In this type of the polymerization reaction, the product that is formed after every step is again a bifunctional species. Exactly. So while some two bifunctional monomers will attach with each other, so while they are making the monomer, that monomer obviously should have the bifunctional bifunctional species. Okay, so this species undergo a sequence of the condensation process. At each step we have distinct functional species. Every species is independent of the other species, so we call this process as a step growth. The addition polymerization, for the addition polymerization, that we have chain growth, and this is the step growth polymerization. Examples, so yeah, condensation polymerization, the examples are like nylon 6,6, okay, tartalic acid, in this ethylene glycol and tartalic acid while attached with each other, and again it will make the condensation polymer. Okay, so this is the what I say about the tartalic acid and ethylene glycol. While they are attaching with each other, it will make a polyester. Okay, now look, you can see it, tartalic acid group we have. This is the acid group, C double bond O, C bond OH. Okay, this acid group first will react with the ethylene, the 1,2-diol. Okay, so diol means the hydroxyl group we have, OH group. So this hydroxyl group will this hydroxyl group will react with the carboxylic group, and it will make, you can see this the OH group of the carboxylic acid will attach with the hydrogen of the hydrogen atom of the hydroxyl group of the next monomer, and thus the N molecules of the water molecule will be eliminated, and it will attach with the carboxylic acid, tartalic acid, and the ethylene diol 1,2-diol will attach with each other, and it will make the ester, polyester, which we have the ester linkage, COOC2H4. Okay, this is called ester linkage. Again, this is one more example is that is condensation polymer, that is the amino acids. Okay, so like one amine and one acid while mix with each other, and it will make the amino acids, and while n number of large molecules of amino acids are attached with each other, it will make the protein. So generally in protein we have the amino acid linkage. That means one acid, the basic moiety is acid, carboxylic acid, and one amine group we should have. Okay, and this is the another example of nylon. Okay, nylon 6,6, where we have hexamethylene diamine and adipic acid. This is the hexamethylene diamine. That means you can see two amine group we have, and adipic acid, that means we have here carbolic acid. Okay, carbolic acid, carboxylic group. Carboxylic group, we have COOH, carboxylic group. So these amine group will react with this carboxylic group COOH, and after all it will form the nylon 6,6 and eliminating some of the water molecule. Okay, so this is the whole mechanism where whole mechanism of the condensation process. Okay, so we can see here the monomer should be the bifunctional monomers. Like if one moiety will have the carboxylic group, one moiety will have the amine group. Okay, so bifunctional moieties are attaching with each other and eliminating some water molecule, some alcohol molecule. So this is called by the condensation polymer. Okay, so these are the some of the examples again of the condensation polymer, like nylon 6,6, the monomers are adipic acid and hexamethylene diamine. So this is the structure. Again, these are the some of the uses of the polymers that you have to remember. For nylon 6,6, you know, for ropes, for making the ropes, fabrics, clothing, the sports wear, all these are made of the nylon 6,6. Now nylon 6 caprolactam is the monomer. This is the structure and mainly used for making the cords for the types of ropes and the fabrics. Now polyester, polyester, as I told you and we have seen already, that is ethylene glycol and tartalic acid while mixed with each other, it will make the polyester. Okay, so this is the safety, some of the fibers, this resistant fiber, crease resistant fibers. So safety helmets generally we are making by using this polyester. Okay, phenol formaldehyde resin, this bacilli already you have synthesized in the chemistry lab. So phenol and formaldehyde are two the monomers. This is the structure of the bacillite. Generally bacillite are the use of the bacillite in the switchboard. Bacillite is one of the example of thermosetting polymer also, that is the for the network structure it is heard, that's why in the switchboard we are using the bacillite. Okay, so these are the some of the examples of common condensation polymers that you have to memorize, because from this portion you can have the question like this, for bacillite what will be the monomers. Okay, what is the use of polyesters? To write down the structure of nylon 6,6. So these are the some of the questions that you are frequently asked in your exam from this portion. Next we will see what are the conducting polymer. Conducting polymer generally that means which can conduct the electricity. So while we have this conduction of the electricity, that means we should have the extra electrons. Okay, so conducting polymers are the generally while we have the unsaturated molecules. Okay, in this conducting polymer, while we have the alternative double bond, alternative triple bond, for this case we can see that pi electrons can the move, and thus they can they can carry the electricity. Okay, so this is the conducting polymer, and electric current results of the orderly movement of the charges in a material as a response of forces that act on them. When a voltage is applied, the positive charges flow in the direction of the electric field applied, whereas the negative charges move in the opposite direction. The movement of the electron will be opposite direction of the positive charge. The structure of this material has conjugated chains. As I told you, the conducting polymer, the special features of the conducting polymer should have the alternate conjugated should be the conjugated system. That means alternate double bond or triple bond. Okay, alternating double bond between the atoms. The process of doping of conducting polymers between becomes easier due to the conjugate bonds. The charges resulted in the doping process in conductive polymers is the reason of their great conductivity. These are the some of the conducting polymers that we have, that is like polyaniline, okay, polyacetylene, yeah. So this is polyaniline, one of the example of the conducting polymer. Again we will see the structure also. If we look at the structure, that time you can understand why these polymers are conducting electricity. Polypyrrole. So these are the some of the examples. Now what is the application? These type of materials are generated interesting in many field of study due to the conductivity properties, conducting properties. Okay, so polypyrrole, polyaniline are currently used in protection of metals. In the medical field, the conductive polymer can be used in production of artificial biosensors, okay, drug controlled release agents. So these are the some of the examples of the fields where the conducting polymers are generally used, applied. Okay, now you can see here polyacetylene. That means look here, we have double bond, alternate double bond, right? So these alternate double bonds are responsible for the conductivity nature. Polypyrrole, again the alternate double bond. Polythiophene, polyaniline, you can see here the alternate double bonds that we have. So all these conducting polymers are having the conjugate double bond or triple bond, which is the main reason for their conductivity. Okay, so also from this portion you can you may ask this type of question, give some examples of conducting polymers, their structures, write down the structures of their conducting polymers. Okay, next topic is biopolymer. Biopolymer is also very important because these polymers are biodegradable and biocompatible. Okay, generally biodegradable biopolymers are two types. One is agropolymers, one is biopolyesters. Okay, agropolymers again of two types. One is polysaccharide or protein, and biopolyesters like some of the microorganisms, and synthetic polymer, but synthetic biopolyesters. Okay, that synthetic polyesters again natural monomer and synthetic monomer, again divided into two portions, that is natural monomer and the synthetic monomer. So these are the some of the examples of biopolymer that we have generally used or we can see in our nature, that is cellulose, chitosan, okay, then gelatin, polypeptides, lignin. So these are the some of the biopolymers, and these biopolymers are huge. We can use these biopolymers for making the biocomposites or bio nanocomposites, and which is used in recent years, which is used in the medical. There are so many applications field that we have in the like medical field. Also we are using this biopolymers for biocomposites, bio nanocomposites. Okay, so the benefits of the biopolymer: these polymers are generally the carbon neutral and can always be renewed. Okay, these polymers can reduce the carbon dioxide levels in the atmosphere and can decrease the carbon emission. Obviously, this if we use the biopolymers, that is eco-friendly, and obviously the carbon emission will be decreased. This will happen because of the biodegradation. They are all these biopolymers are biodegradable materials. Okay, it is also compostable, which means there is less chance of environment pollution. These chemical compounds reduce the dependency of non-renewable fossil fuels. Exactly. So if the biopolymers are environment friendly and renewable, so that these compounds we can use instead of using the non-renewable fossil fuels. These are easily biodegradable and can decrease the air pollution. These are the some of the beneficial use of the biopolymers. Okay, so these are the different field that we can use the in which the biopolymers can be used, like as the coating material, fibers in the plastic, adhesive as the adhesive, as in the cosmetic industry, oil industry, paper industry, textile industry, in water treatment also we can use the biopolymers. In the, as I told you, the bio, there are huge applications we have in the biomedical field, also in the pharmaceutical field, automotive, and also in the rubber industry. So these are all the industries that we are using. Generally we are day by day we are using the biopolymers. Okay, here also you can see the biomedical polymers. That means the applications of biopolymers in the medical field, like drug delivery, scaffold. As a scaffold also we can see scaffold of the medicine, medical implants. For the medical implants also biopolymers are used. Okay, anti microbial membranes, skin tissue repair, biosensors. As the biosensors also these biopolymers are used. Okay, so these are the some of the medical uses use of biopolymers in the medical field, which is very promising. Okay, yeah, so this is the end of the chapter, end of the polymer chapter, and also this is the end of the today's class. So how much you have understood? For checking that, I have given one question, that is give one example of conducting polymer. So for that you have 10-second time. Your time starts now. Yeah, your time is over. So the, yeah, you are absolutely right. Polyaniline is one of the example of the conducting polymer, or polyacetylene. Okay, so whatever the polymers we have that is having the conjugate double bond and triple bond, that means alternate, the double and triple bond are in the alternate position, that can be the conducting polymer, that can conduct the electricity by the delocalization of the pi electrons. Okay, so these are the some of the examples of the conducting polymer. Now this is again the recapitulation. So we have discussed about the classification based on the polymerization reaction. biopolymers, we have discussed what are the biopolymers, what are the beneficial benefits of using the biopolymers, and also we have seen some of the examples. And these are the conducting polymers, why they are conducting, what is the structural features, if they are conducting the electricity. All this we have seen. Also some of the examples we have seen. So yeah, checked. Okay, so students, this is the end of the polymer chapter. Please follow the classes regularly and properly. And I have given one assignment also, so which you have to submit in time. So if you can't follow the classes, if you don't follow the classes, then you cannot do the assignment in time and submit it in time. So thank you students, and see you in the next class.